little bit change. Today we will start from program. Okay. I see your homework. I think there's a few problems. One big problem is some of you didn't send me all the file I need. Okay. Some people didn't send me the waveform. Some of you didn't send me part of your program. Some function I need to run the program. I don't have them. And so I suggest you that you can make a folder for every time's assignment. Then you can copy all the things you need. You can get in the old file, all the old file copied here, but delete anything that you don't need, and just left something you need, and then programming start programming. Okay. I copied my fifth times programming here, and I'm starting to do a little bit of change. First thing, I put my structure setting parameter here, and this time I set a little bit a nonlinear parameter here. Okay, the nonlinear parameter we used to decide nonlinear other parameters. For example, we have AY, so we have FY equals to M multiple G. I'm setting here at 9.8 multiple EY. Okay, so if I run this part, I will write my FI here, right? And so maybe I should also need my dy. My dy will be my FI divided by K1. Right. Maybe sometimes I mean by Q, my critical force, which is equals to 1 minus alpha time FI. Okay, so all the things different. Oh, sorry. Okay, sorry. This part, this you should see. Sorry about that. Okay, I will explain it from start. This is my old program, a new map beta method, and so I'll maybe change a little bit. Nonlinear new map beta method calculate structure response, and I put my structure parameter here. Okay, beta, mass, stiffness, and damping ratio, and G 0.8. All here is unit of Newton, meter, seconds. All of them is in this unit system. And I have my alpha, which is the first and second stiffness ratio. And AY is my yielding strength. AY means that FI is AY time of G that will acting on the mass. Okay. So structure stronger than 0.3 G, then structure will be yield. And so that we can calculate all my nonlinear parameters here. This part we did it last time. This is a ky equals k because ky is the first stiffness. So we already set k here as a structure parameter. And k2 equals k multiple alpha because alpha is the first and second ratio. And fi I just explained, and dy is what you need. And q is critical force we talked about last time, right? Because the nonlinear force will be crossed with the force direction when displacement equals 0, will be critical force. And input earthquake, okay, this part we don't have any change, right? AG, we use we set it as 4,000 times here from 1501 to 550 hundredths. and we divide by 100, so we change them unit to meter per second. Because what we get is about meters. So we plot waveform here, unlike this, and we do the numeric beta method here. Okay, and here we output all the output things, but we change a little bit the output. Here, my output, we don't have any argument here because we don't need any argument. And I put y1, y2, y3, y4 here. A lot of you already done this. And last time I forgot to put change line mark here to \n, such as I put it here. If you didn't have it, please put it here. Okay. And same thing is happening here, but I just put xi every time, every loop. Use a very low level of writing things here. Okay, we can also have one better way to do that, but this time we didn't show it clearly here. But this is the most basic way to do it. So you can edit every line you want, but with a for loop. And finally, don't forget to close the file. Okay? It's also very important. Okay, so the most thing that I need to change is numeric beta incremental method. Okay, so this time we will change them. Where is it? Here. So I will show you how to change function file. Okay, when you're changing a function, you edit a function that you change 3 things of them. I mean the name. Firstly, I will say nonlinear. Okay, incremental nonlinear time in t duration. Okay, maybe pretty long. Okay. So you may see that this part becomes yellow, some orange, and we mark some waves here. This is because that my file name didn't match with my function name. So what I need to do is to save as the correct file name. I change correct my file name here and save them to here. And I will get a new function here. So I just delete all the file. Okay. The second, change the file name. Okay. The third thing is we need to change the file name that we used in the function, in the main script. Okay. And there's also a few parameters that we need. It's K1, K2, dy, Q, right? And also we need to output the force, nonlinear force, F. Okay, so this may be a little bit changed. So I just copy them to my file, delete the semicolon part. So K1, K2, dy, Q didn't use yet, so they becomes yellow. And firstly, or M heart will be changed to M heart 1 when we use K1. And so this time I think we better calculate the parameter every time, because K is changing every step. So I will just put them here. sure every time they are updated, because every step k may be different. And right now k is equals to k1, and we get my incremental of ag, and I calculate df and calculate everything. So before end, I'll calculate my f, which is fn equals 0, and f equals to fn plus k multiple dd, okay, where dd should be this one without dn, and dn1 will becomes dd, dn plus dd. Right? So this is where we get my or f. So we'll memory this f, goes f, and we will record update or fn as we did adding time. So here is the same with the linear analysis, right? So that's why when we run the program, it should comes out with the same result, right? Come out with the same result. So anything, change a lot of things, but anything wrong here. So we just do the nonlinear part. So if I find something wrong, that must be nonlinear part is wrong, right? So writing my code here. So this is nonlinear part. Firstly, what we learned last time is if now is elastic, right? What's wrong with my indent here? And we will check if our structure is ill or not. So firstly, we say dc equals 0, and we'll check if the d1 minus dc is larger than dy. Do I have dy here? We have dy here, right? If so, if they are larger than, so we need to firstly we need to change k to k2 because it's nonlinear. And that's all. That's also let's just do it like this, right? And here's n, but we will say else. If now is not elastic, it's plastic. So what do I need to check is dd multiple ddn smaller than 0. So change direction now. But we don't have ddn, so we check ddn here. 0. Incremental of dd. So ddn equals to dd. Okay. If they are equals 0, then the direction of the movement of the vibration changed. So I need to change back to k equals to k1. Another thing is that we need to change my DC equals to D and 1 minus which is also should be DDN divide ABS BDN. So I hope you remember what is this meaning. This means if we are on the minus direction, then this part will becomes minus automatically, and then we will change or divide another way. So update or DC. So and for this one and for if. Okay. Very simple part. Only this part is nonlinear part. So save the step and update. Okay. So it should works. But we cannot see the relationship of force and displacement, and so we will need another one. We need but change the velocity to D and F, so we can see the hysteresis curve. This is D, which is F. Okay, it's nonlinear part. I hope we don't have any limitation here, but this is kind of like we go to here and go to here, but okay, no positive part. Sorry. No negative part because we changed the x limit here. Let me comment this part, and you can see the whole history curves here. Okay, you see the whole history curves here, and so if my yield force becomes smaller, then the nonlinear displacement will be larger, right? Let me show you at last as we can. Figure 1. Okay. So also we can change here to alpha to 0. And still this works, right? Still this works. Okay, still this works. Let me put this figure larger. I will create another two, compile them independently. Okay, maybe I need bracket here. And you can see what do we get here. it's pretty works pretty well, but there's some part that's not so beautiful. Okay, actually, this part is ugly. Okay, this part ugly. This is not on the same line. Actually, it's not the real nonlinear part. Some of you, okay, this is good enough for me, but maybe this is not very reality for all the case. Maybe not very good. This is, you cannot see any different from here. But if we have smaller, okay, we will have more something like this. But be very very bad, right? So why this things happens? You may realize that in the we're now in the t is not very large value. T is about 2 seconds, right? It's a little bit long period. If we have a stronger period and even smaller yielding force, you can see that still very large response, right? 3. You can see the displacement will be very very strange. So this is mostly because that we didn't do it correct. Let me explain to you.